All right, how's everyone doing? Excellent. Yeah, that's a good wake up. All right, any PA3 issues? Or issues with getting Eclipse going, or any of the stuff we've been doing? So it's a Friday, and it's been a week. So, what I'm going to do today is just kind of go through, from sort of a high level perspective, some of the things that we're going to be doing in the next few weeks. I want to go into Eclipse and just look at some of the basic building blocks that we get from Swing, and get an idea of the kinds of things we can do with them, how we can hook them up and interact with them through code, and so on and so forth. And I'm not going to go into, particularly deep detail on any of this. We'll drill down to it in the coming classes, and when we get to PA4, we'll get very specific with certain aspects of this. But I want to kind of use this as a mechanism for introducing some of the general concepts related to GUIs and making and working with GUIs. And it's going to involve a kind of fundamental mental shift in how we think about code compared to writing code in C, or the way we've been writing code in Java so far. So let me open up Eclipse in here. So I'm out of my virtual environment now. I just did that for being able to install this stuff from starting from zero, but I'm in my regular Eclipse environment. Unfortunately, it insists on popping up in my other window whenever I do anything, but that's okay. So let me close this project and let me delete this project. And I tried to make a special work area for this class, but I typoed and called it 222 instead of 223, so that's why it says 222. I get these messages down here because Eclipse is a general development environment, so we use it for playing around with Java and Swing. But I have a running swimming biking watch made by Garmin, and it comes with an SDK, a software development kit, and the development system that they have for writing apps for this watch runs as a plugin through Eclipse. So I have an extra tab up here, Connect IQ, that will interact with that set of software. So Eclipse is probably not the most popular IDE anymore. So I think IntelliJ is used a lot more, and Android Studio switched over to IntelliJ a while back, and that's a big boost. But Eclipse is still used by a lot of developers, a lot of things that you'll get. You might buy a drone and it comes with, a software development kit, and you might find a plugin for Eclipse that lets you work with that. In some sense, the more you work within an IDE, the more uniform the experience, right? It takes away a lot of the sort of details that you would otherwise have to learn that you might not be interested in, right? I don't want to learn the whole tool chain for developing apps for my smartwatch, right? So I just do it inside Eclipse, and somebody already bundled all of that up for me. So this is a useful tool, and I think WSU gives you your choice of what IDE you want to work in, and some people choose Eclipse, some people choose IntelliJ. So let's do some development here. So I'm pretty much always going to do a new Java project, and I'll just call it main 223B. And if you've got the latest version, you definitely want to click through on next and uncheck this box that says create module info file.java. I've got an older version of Eclipse here, so it doesn't check that automatically, so I can just say finish. And then let's make a JFrame. All right, so I'm gonna right click on this. You can either right click and say new, or you can do file new. It's kind of the same thing. But I'm gonna do other, and I'm gonna come down to window builder and swing designer, and I'm gonna pick a JFrame. And that's pretty much always gonna be the top level class that we use to build our GUIs. So I'll do a JFrame, and I'll pick a name, and I'll just call it mainframe. Window builder under new. Yeah. So file new other window builder swing designer. Oh, there's probably other ways to get to it. Yeah, it's under other. Although sometimes it moves up into the top level of options under new. Alright, we're going to keep working with the default package for now. Packages are basically a way, though, to take a collection of classes that you're developing and sort of put them into one area. So it's in practice, it's really just a subdirectory under a tree. But it lets us, have multiple classes with the same name, but they're distinct from each other because they're in different packages. And then if you want to use my, fractions package, you can do an import statement. And when you refer to a fraction, it will look in a path corresponding to that package for the class that you're asking for. Since we're just developing, one thing at a time for ourselves, we don't have to worry about this. And so we'll go ahead and use the default package, even though the use of the default package is discouraged. Well, I'm encouraging it, so it's sometimes discouraged. So we can leave this blank, right? And if you put something in here, then it's going to get confusing how to run this and how to find the source code and the class file and all that. So leave that blank, and we can just click through to finish. And then there's our Java code, right? So this was created for us, and like IntelliJ and Studio and all these other things, right, we can switch between a visual representation and an actual source code representation. So if I click on the Design tab, here's what the code will produce if I run it. It's going to be an empty frame, it's going to be this color, and it's not going to have anything else on it. If I click on the Source tab, right, that will show me the corresponding Java code. And if for some reason you don't have a Design tab, you can always come over here, right click, and then say Open With, and force it to open with Window Builder. And sometimes if you throw this in the backup and you restore from the backup, it'll forget that, that you want Window Builder. So you can always open it up like that too. This crashes sometimes. It crashed once this morning. Save your work often, just hit a Control-S. And that will save. Even if you're using VWrapper for VI as your editor, you can still Control-S to save, unless you unbind that. All right, so let's, we can run this. And like I say, all these windows pop up on my other display. But there's our frame, right? It doesn't do much. We can close it out. When we close it, this little running button will gray out, and it'll tell us that our process terminated. Okay, so something to notice in here. We're not gonna take apart all the code that gets written for us, but let's just take a look at the main method here. So our class is called mainFrame. We already noted it's extending a JFrame. It's using a JPanel, whatever that is. We're declaring a JPanel called Content Pane. We have a funny looking comment here with 2 asterisks in the beginning and 1 at the end. We'll talk about that later. Here's our public static void main string bracket bracket args. So this is our main program. And it's a kind of strange looking thing. But there's something called run. And this is what's going to run when we say, execute the main class. And let me throw some print statements in here. So I'll print out a message here in the beginning saying I'm starting main. And then at the very end here, I'm going to say leaving main, and I'm going to do a return. And I'm going to spell it right, not a ret run. All right. So I'm going to say starting main. I'm going to do this stuff. This is going to construct an object of type mainFrame called frame. Okay, what is mainFrame? It's this class that we're in. So this is calling the class's constructor, and a mainFrame is an extension of a JFrame. What does the constructor do? Well, it does a few things. It calls some methods like set default close operation, set bounds, and so on and so forth. Yeah, we're coding mainFrames here. All right, so it's constructing one of our objects, and then we're calling a method in this class called setVisible. Right, and that's all we're doing. We're calling constructor, we're calling a setVisible method. And then we're going to print a message saying leaving and return. So a few things to note in here. The first thing is, when I run this, you know, there's my window. It said starting main, it said leaving main. Presumably it executed that return. My main program is done. But my running button is still red, and it hasn't said terminated yet, and I can still, you know, interact with this frame that we created. And if I add buttons on here, I can still, you know, click those and have code execute and so on and so forth. So what's going on here? Here's our main, and it starts executing and it exits, but we've still got some part of our program running. So this is the idea of threading. We have two threads. So a thread is basically like a process. Not exactly, but close enough. When we have, let me close this out. When we have this kind of language here where we say make a new runnable and we make a run method and so on and so forth, what we're doing is we're creating a second thread. And this exits, right down here after it prints out leaving main, but our whole program doesn't terminate yet because there's another thread running. Where is that thread running from? That thread got created when we constructed our JFrame, right, which we're calling a mainFrame. So when this happens, that creates a new thread. So we have two things executing at the same time, and then the thread that's executing main terminates, right here. It returns. But this other thread is still hanging out there. All right, we're going to spend, you know, a week later on just playing with threads and deliberately creating multiple threads and having them interact with each other and looking at ways we can get into problems with that and how to resolve those problems and so on and so forth. But for now, just be aware that when you're using Swing, which is the thing that's making these windows and such, we're doing threaded programming. So we're running more than one process at a time. Now, if you have a single core on your CPU, you're not really running more than one thing at a time. A single core CPU only does one thing at a time. It does one assembly language instruction, one machine language instruction, and it's only servicing one process. But it's going to, you know, switch back and forth really fast between them. If you have multiple cores, these may actually be running at the same time instead of, you know, sharing a little bit of time on each and so on. And so one of the nice things about Java is it lets you do this multi-threaded programming. It's a really easy way to do parallelism. Easy to set up, but making parallelism work the way you want is always tricky. New Java project for the project, new other JFrame for the file. Yeah. Thank you. All right, so what is a JFrame? Right, it's a class. It comes from a frame, which comes from a window, container, component, and an object. We can construct it a few ways. We can construct it with no arguments, or with something called a graphics configuration, or with a title, or with a title and a graphics configuration, right? Your choice. And then it has all these methods. And we're not really going to interact with these for the most part. we're going to let Window Builder manage most of the details of working with these classes for us. Yeah, I think I did a little bit with forks in 224, but not a whole lot. But when you get to 360, if you're going WSU, when you get into 360, you'll be doing a lot of forking in C and playing with threads and P threads and all kinds of stuff. So you'll definitely get a lot of opportunity to play with that. But we will do some threading in here, which will be threading in Java is a whole lot easier than it is in C, and easier to get in trouble. All right, so Window Builder set up these things, right? Default close operation, boundaries on the frame, and so on and so forth. We can also manipulate the frame from this window. So, for example, if I just click on this to select the frame, I have a properties section over here. So that's the type of class it's coming from. We can say, you know, should this always be on top? Well, if I run this right now, I haven't tried this, but we'll try it right now. Right, so there's my frame, but it's, you know, hideable as usual. What happens if we check always on top? And we go ahead and run it. And I'm going to tell it to always save before running. So there's our frame, but, you know, it's always on top. Now, what did checking that box do? It changed the source code. So down here in the constructor, set always on top to true. Set always on top, that's a method that's either in the JFrame class or in one of the classes that JFrame extends. So if you want to know about that, you can go to the JFrame documentation, and I'm just going to search for set always on top. So that's inherited from window. And if you click on that, well, you get, you know, a little essay on what this method does. So that's whether the window should always be above other windows. It takes a Boolean, and it can throw an exception. Yeah. But you can put other things always on top, and they'll be always or on topper. Like I make my chat and participants windows sticky, so that when I move from one desktop to another, I can still see them. But I think they're automatically always on top of the others too. So we can choose, you know, what we want this to do, and there's a bunch of options in here, right? So so the background color, we can click over here and, you know, get a really annoying background color like that. And sometimes that does something obvious, sometimes not. Alright, this is the default exit on close option. And if I click on that, I can choose, right, what I want it to do. I can do nothing on close or hide and so on and so forth. And again, whatever we select there basically just changes our code. So these two views of our class are linked to each other, and it's easiest usually to make changes over here, and they'll be reflected here. But sometimes when we want to put in code to, you know, do something in response to an event, for example, we'll have to put code in here. But you want to be a little careful where you edit in this file. If you just start making random changes in here, you can confuse Window Builder pretty easily, because when I click here to go to the Design tab, it basically interprets what's in the source code and tries to display what the object should look like. So if I get rid of this set background color, and then I go back to my Design tab, Now it's gotten rid of that red. Alright, so different options you can set down here. You can put a title on it, and so on and so forth. You can also click this button right here. I have no idea what that button is supposed to mean, but it's for showing advanced properties. And now you can get to all of the properties available for this particular class. And this you find in every IDE also. There's like, you know, basic properties and then more advanced properties and so on. All right, so there's our JFrame, and inside the JFrame is a content pane. Okay, that's something called a JPanel. JPanel is another kind of object that's part of Swing. And frame is kind of a holder for other things, but usually what we have the frame hold is a panel or a collection of panels. And then the panel is where we actually place things like buttons and drawing areas and text areas and so on and so forth. But you can set this up however you like, right? And part of why I want to go through a lot of this in very little detail right now is that if you want to start messing with this, right, over the weekend perhaps, this is a good point in the course to begin playing with this. And you know, you can buy volumes of books that tell you all about the different Swing components. I could lecture for, you know, 20 hours all about it. Nothing's going to match the experience of just messing around with this stuff, right? What's you know, what do these different layouts do? What are these different components? What are struts and springs, you know? You can just drag and drop and play and experiment, and occasionally, you know, go and read the documentation, because all the stuff that you're going to find in here you'll find on the Oracle documentation. But really it's you know, it's like learning Scratch. Just drag and drop and experiment, hypothesize, try, modulate, try again, and so on. Absolute best way to kind of get familiar with this. And you're not trying to become an expert on J buttons or, you know, a J text field or things like that. You're trying to kind of get a general sense of what sorts of things can I do, right? And then when we start working on PA4, where we're building, you know, a visual game, we've got some idea of like what's in our toolkit basically. So let's continue developing this. So so layout managers. You know, here I've got a window for Eclipse, and it's got, you know, a few different sections to it, and it's got a menu bar, and it's got some buttons up here and so on. And if I grab a corner and I resize this, right, it does something fairly reasonable, right? No matter how big or small I make it, this bottom bar stays the same size so that I can read it, because that's got information. The menu bar stays the same size. But as I squish it down, right, all of these other fields kind of collapse, you know, roughly the same. If I stretch it or shrink it horizontally, right, it's working to still show me a little bit of each area. I can still see my layout area over here. And, you know, I can move some things around if I have enough space. I can shrink them and grow them and so on and so forth, right? Now, if you design a window by just putting down a JFrame and say, I want this button right here and I want this text field right here, what's going to happen if you change the size of the window is your objects are going to appear and disappear, right? So usually you have what's called a layout manager. And the layout manager is what's saying, you know, hey, the window is getting bigger. Let's make this area wider, and let's move this over to here, and so on and so forth. And there's a ton of layout managers. So you have a choice of those in here. So there's a border layout, a grid bag, a box, a form, a group. There's a MIG, which I actually like a lot, Spring, and you can download other layouts and so on and so forth. But I'm going to say don't mess with them too much right now. I mean, you can play with them to experiment, but when you're trying to make a GUI, you don't have to worry about it. Okay, so I'm not going to require your GUIs to be resizable. right? I'm going to say, you know, if you're making a GUI for a game, you can just make it, you know, 800 by 600 or something like that, and place the components where you like. But if you want to play with these, right, they can be a lot of fun, or they can be frustrating, or both. So I'm pretty much going to work with just an absolute layout, which is saying, you know, don't do any kind of management. Just place things where I place them. So I'll click on that, come in here, I get the green area, I'll just left click, and that places the absolute layout manager. And now we can place objects. So let's put a button over here, and let's put a text field right here. And I don't know, we'll put a checkbox right here. And I'm going to save this often. All right, so if I click on the new button, right, here's all the properties. Let me shrink this down again. Here's all the properties of the button. I'm going to go back to just showing the basic properties. So, you know, here's the text of the button. So if I wanted to say something different, I can type something in here. You know, so this is my launch button. And my checkbox, I can change the text, and so this is the Send All Money to Evil Corp button, and we got to make it wider. There we go. And that's just a text field. Now, if we look at the code at this point, the code's quite a bit more involved. And I'm going to shrink this down too. Right. So our main program is still the same, but the constructor for our mainframe is now doing all these other things. It's creating a J button, right? And it's using the constructor that takes a string, which lets us specify the initial label on the button. It's setting the bounds, so the location and dimensions of the button. And then the content pane, which is our J panel, it's using an add method and saying add button new button. That's the name of the J button. So this is basically placing the J button on the panel. And the panel is inside the frame, and the frame is the whole window. Here we create a text field. We set its bounds. And then we add the text field to the content pane, the J panel. And we set it to be 10 columns wide. And here's a checkbox. And there's the bounds on it, and that gets added to the content pane. And the content pane is part of the J panel because this is the constructor for mainframe, right? Remember, mainframe is a JFrame plus some other stuff. And right here, I call a method which is called setContentPane. What is setContentPane? Well, it says what is the name of the object that should fill, you know, that main area of the JFrame. And I pass it the argument ContentPane, which is my JPanel. So this statement right here adds the JPanel to the JFrame. This gets rid of any layout manager. And then these add different components to the panel. Now we can do this by hand. We can go into VI, we can write this code ourselves and compile it and run it, and it works exactly the same. Window Builder just basically, you know, knows how to do these things in response to where we place these components and how we change them over here in this layout. So if we want a big launch button, we can just come here and make it really big. And now when we look at the source code, the constructor for the J button says, you know, make it 135 pixels high. And if I change this, yeah, definitely, because, you know, you're always being tackled as you're trying to hit the launch button. So you want to make it big. So, and if we make it small, right, change that to 35 and go back to the design window, right, we're back to a small button. So we can also rename our variables. So this text field is called text field. Well, I could change this to, you know, message. And now if I look in the source, this text field is called message. All right, so these are tied together. I guess this should probably be. Got to show respect to Evil Corp. All right, so let's talk about events. So up to this point, at least in the classes that we've had, 224, 22 so far in this course, right? We've been writing programs that I would call procedural, meaning they basically start with the beginning of some sort of main program and they just proceed step by step. And we do if statements, we do loops to go back to previous statements, we call functions, do some things in return, and so on. But we're basically, you know, we're always executing some line of code from our program. And if we're waiting for something to happen, we might, you know, do a while one loop, or, you know, while this thing has not happened yet, do some stuff and go back and check again and so on. But basically, you can look at your code and you know that there's always some line of your program that's executing. Maybe it's a read statement, you know, an fgets or something like that. But your program basically describes exactly what the CPU is going to be doing. Okay, that's one way to write code, and I call that kind of procedural programming. But we're going to be doing something different from this point on. We're going to be writing what's called event-based code, or event-triggered code. And if you've done Engineering 270, there's a lab where you hook up 3 LEDs and they're blinking 1, 2, 3, 1, 2, 3, 1, 2, 3, and they just keep blinking forever and ever and ever, right? Until somebody flips a switch, and depending on what switch they flip, now the pattern changes, and one of those LEDs lights up for a few seconds, and then it goes back 1, 2, 3, 1, 2, 3. And nowhere in your code are you checking the value of that switch. If you look at the main loop of the code for this lab, all it's doing is, you know, turn on the first LED, sleep for a second, turn on the second, sleep, turn on the third, sleep, go back to the beginning, and do it again. And nowhere in that code do you say, you know, is this button being pressed? If it is, let's do something else. So the way that lab works, you set up an interrupt handler. And you hook up that switch so that when the switch gets flipped, it triggers an interrupt request. And what you do is you write an interrupt handler, a piece of code, you put it at a particular location, and you set things up ahead of time so that when that flip occurs and you get 5 volts applied to a pin, your CPU will stop what it's doing and it will jump over to some other location and start executing this other code, which we call an interrupt handler. Okay, that's the same thing we're going to be doing in our Java code. And here's the reason. If you look on a typical machine, right, we've got 300 some tasks running, or, you know, sitting around in our machine. But most of them are not doing anything. So I have 2 tasks running right now. One of them is called Xorg. That's the thing that's managing my display and overheating my CPU because I have to reboot. The other thing is this process called top, which is right down here. And that's the program which is doing this display. And when it's at the point where it's trying to find out the state of processes, top is running. But all these other processes, right, 250 of them, are sleeping. All right, so what does that mean when we say a process is sleeping? So our main program does this, it constructs a frame, it makes it visible, and then it exits. And at that point, our Java program is sleeping. It's just hanging out in the background. But before it went to sleep, it set an alert. Okay, it talked to something, we can think of it as the operating system, and said, hey, if this corner gets clicked, let me know, because I might want to do something about that. If somebody clicks right here, or somebody clicks right here, or somebody clicks right here, let me know, because I might be interested in that. And so the way we're going to write programs in Java using Swing is we're going to basically set things up ahead of time to say, hey, when certain events happen, start executing this code and do these things. And outside of that, our code's not going to be running. It's going to be asleep. So suppose I want to write code for this window so that when you hit the launch button, it prints a message in here. Now, in kind of a procedural way, we might do something like, you know, a while loop. While the button is not pressed, go back and check again. Or, you know, while one, if the button is pressed, then set the text in here to be such and such. And we would sit here and we would just continually keep checking to see if the button's been pressed. Is it pressed? Is it pressed? Is it pressed? Right? If you have a few hundred tasks on your system, all of them doing things like that, your CPU is overloaded. So we work with the operating system. We tell our process to go to sleep, and basically the operating system will wake up that process when it needs to do something. And this is why we can have, you know, hundreds of processes coexisting on this system without bogging it down. So if we want to respond to an event, we can right click on a widget and we can say add an event handler. And we can choose a variety of events to respond to. So depending on the type of widget, action performed might mean different things. For a button, action performed means you press the button. For a checkbox, it means you checked or unchecked the box. But for other things, it might be different. Why is my network cable disconnected? Oh boy. We can ask for the state changed. So for a checkbox, going from checked to unchecked or vice versa will correspond to a state change. We can ask if the component has become hidden or moved or changed size. We can ask if a piece of our window has gotten focus. I think I'm losing my connection here. Oh boy. Yikes. Alright, that was awkward. Thank you. I don't know what that was. I actually had a message on my TV saying network cable disconnected, and then it went south. So I don't know how long ago I got dropped. You're in the middle of action performed. Okay, that's not too bad. Back when cell phones were first kind of still a novelty, I'd be like talking on my cell phone. I'd be going on and on and on for like 10 minutes, and all of a sudden, while I'm talking, the phone would ring because I'd gotten disconnected and didn't notice because I'd just been like rambling on. All right, so we can set actions on these. So add an event handler so we can do action performed. Yeah. We can respond to a widget gaining or losing focus. We can respond to a key press or a key release or the action of pressing and releasing, which we call typing. We can respond to mouse events and mouse wheel events and so on and so forth. I think we're still recording. I don't think that was affected, but you'll hear recordings of me like mumbling about being disconnected. But thanks for reminding me to check. All right. So let's hook up some events. So if you want to respond to a mouse click, right, one easy way is just double click the button, and that will crash Eclipse for you, and that gives you a chance to restart it. But hey, it survived a network drop, so. Alright, so go back into our design window and we'll double click on the launch button, and that brings us into a new section of code. And what is this doing, right? So that's where we constructed our J button. This was where it set the boundaries, added it to the panel, but this is new, right? So it's calling a method for this button called add action listener. Well, an action listener is basically a way to say, hey, when something occurs, let me know. And we could put the name of a method in here, but this is doing what's called an inner class. It's actually defining the method that we want right inside here. But we don't have to worry about that for now, right? It's creating this blob of code for us. We can just come down here and we can tell it what we want to do when the button is clicked. So we'll just print out a message. And we can go ahead and run that. And when we hit the launch button, it says click. Alright, so what about this text field? Uh-oh. I'm sensing a class. Oh, I changed the default action to not do anything when we close the window. So let's change that back. Let's go back here and set on the JFrame default action on close. Let's say exit. So now if we run and we hit the launch button, it says click, and if we X this out, that should terminate the program. All right, so so up here we have a text field. We changed the name of this to message, right? So let's go back in here, and in addition to printing out click, let's print something on that text field. So I'm going to just say message. That's the name of the object, dot. And it's going to show me all the things that I could put in here. This is basically a list of all the methods that it knows about related to the type of object message is, which is a JText field. And if you kind of know what you're looking for, this is useful. If you don't, you got to go to the documentation. But I'm looking for something called setText, right? But you can see how many methods there are here. This is because, you know, of the inheritance. Everything is an extension of something else, and each time you extend, you get a whole bunch of new methods. But there's a method down here for setText. SetText, which takes a string. And there's a little blurb telling you about it, right? So, but I'm just gonna type this in, and I'll just say hello. And we'll go ahead and run this. And so now when I click the launch button, I should get a message up here in the text box that says hello. in addition to printing click down here. And all of the stuff can be tied together, right? So this text field, if we right click on that and we say add event handler, we can add a handler for mouse. And we can say if mouse entered, let's do something. So what should we do? I don't know. Let's do something in here. So what is my button called? Button new button. Well, that's a horrible name for a button, right? So I'll call this launch button. So let's say when we enter that text field, let's change the label on the launch button. So I'm going to do launch button.set, and I don't remember if it's label or text. There is a label. And we'll say we're inside our text field. Oh, it doesn't like set label. So, I think it's set text maybe. So these classes change over time, right? And sometimes a set of classes are developed with one methodology in mind, and as things build and develop, new methodologies emerge, and the things we used to do might not make as much sense anymore, and so methods and classes can become deprecated. And so Eclipse, showed me that method with a line through it, and anytime you hover over something in Eclipse, it will pop up a window giving you some information. So it's telling me that method has been deprecated. So I'm just going to use set text, and let's see what that does. All right, so when I move into this area, it changed the text on my button. And crashed Eclipse. All right, so this is just kind of a high-level overview. It's like using Scratch, right? You really want to just kind of like get a feeling for what the options are, what kinds of things are available, and then as you start developing code, you'll start to say, I really want to be able to do such and such when someone resizes this window. Is there a way to do that? So that's when you probably Google, and Google is still your friend, but don't get lost in it, right? Use Google to point you to what you should be looking at, in the Java documentation, for example. But before you can do that, you got to kind of have an idea what sorts of things you can do. Yeah. Hey, DuckDuckGo and Alta Vista. There we go. All right. We are at 2:50, so that's probably a good stopping point. The only other thing I'll mention is like if I add an event handler here for mouse motion, like mouse moved, right? You notice that this method that was created for responding to mouse motion, well, it's passed an argument. It's an argument, they're calling it E. I can change the name of that, but it's an argument of type mouse event. Mouse event is another class. And if I look at the documentation on a mouse event, I see all the different fields that are available and methods that are available for this object E. And I can do things like, for example, get the coordinates, X and Y, of where the mouse was when this listener was activated. And I can get relative coordinates, I can get absolute coordinates, I can get the position of any modifiers. Did I have the shift key down? Do I have the alt key down? And so on and so forth. Right? So all this information is available to us. And it's our job / pastime to basically, decide how to use this to do whatever we want to do. All right, so we'll leave it there for now, and I'll wish you a good weekend. And Monday we will start digging through some of this stuff more methodically and start trying to build up a repertoire of some of these things we can do, working towards PA4. And we'll talk about PA4 probably middle of next week, even though PA3 is not due until next Friday. We'll give you a head start on PA4. So have a good one, and I will see you next time.